This collab includes linear algebra for deep learning. So in the first cell, we create a complete neural network forward pass with two layers performing matrix multiplication with weights, added biases, and applying ReLU and softmax activations. The output shows the probability predictions for 5 samples across 3 classes. And the next cell calculates the L1 and L2 and Frobenius norms on a weight matrix to demonstrate regularization techniques. So the output shows how different norms penalize weights to prevent overfitting. Here we visualize the unit balls for L1, L2, and L infinity normals, showing their geometric shapes. The plot demonstrates how L1 creates a diamond shape that encourages sparsity, with L2 creates a circle. Here we compute L1 Manhattan, L2 Euclidean, and L infinity max norms for vector. The output shows the calculated values using the different distance matrices. So this visualization includes a PC example on correlated data showing principal components. So we have computed and visualized the eigenvectors of a matrix, and show how eigenvectors maintain direction after transformation. First, we verify the eigenvalue equation and for a 2 by 2 matrix. So the output show confirms that multiplying eigenvectors by the matrix equals scaling them by eigenvalues. Here we visualize how determinant affects area when transforming shapes, scaling, shearing, and singular. So the plot show a unit square transformed by different matrices. Here we compute the matrix inverse and verifies that it equals to the identity matrix. So here we can see the output that shows the inverse and confirms the result is the identity. Now here we perform matrix transpose and visualize the row column swap with heat maps. So the plot shows how a 2 by 3 matrix becomes 3 by 2 by after transposing. So this visualization uh, shows the batch processing through a neural network layer with weight matrix, bias, and outputs. Here. Now we perform batch multiplication. The output shows how the entire batch is processed in one operation for efficiency. Here we visualize the matrix multiplication A and B with heat map showing the operation step by step. In the output, we demonstrate how elements are computed using raw column and dot products. This visualization of a matrix vector multiplication showing weight matrix, input vector, and output vector. So the plots demonstrate how each output neuron computes a dot product with its weight row. So here we perform some matrix operations and show the dot product, cosine similarity, neuron product. So that's about this collab.